Hello and Assalamualaikum. We are from Group D10 are going to explain about our mini project in IC Design. My name is Muhammad Ajak Khalis bin Aziz. My number metric is 211011057. As a student number 1, I'm going to explain about simulation waveform analysis. So this is our equation, which are A plus B plus C plus GH bar. This equation will be used throughout this mini project. From this equation, we can create a transistor level schematic by using the method pen and saw. So as we can see here, ABC here is parallel and GH is series. That is for the PMOS, and for the NMOS, the ABC will be in series and the GH will be in parallel. So, and then after that we can proceed to do a waveform. So to do a waveform, firstly we can do the logic gate diagram, which are create from the same equation. Then we create the truth table. For the logic gate diagram, the input for ABC will be connected to the OR gate, and the GH will be connected to the AND gate, and then the Y will be like this. So, and then after we create the logic gate, we can create the truth table. Now let's see our waveform. So as you can see here, when the input A is 0, B 0, C 0, G 1 and H 1, and the outcome will be 1. And so if we can compare it with the truth table, we can see that waveform and the truth table is showing the same result. So let's take another example. So let's see here, we take the 10011 for the input, and the outcome will be 0. So to check whether the waveform is true or not, we can see the truth table. We can check by using the truth table. So it will show the same result. Let's take another example. For example, this input 11010, so the output will be 0. And then again, we can check whether the waveform is correct or not by using the truth table that we create earlier. So here 11010 will be the output will be 0, so it's the same as the waveform, so it's correct. Thank you.
Bismillahirrahmanirrahim, and hello, Assalamualaikum. My name is Muhammad Afishim Safan. So I would like my metric number is 211013373. So as a student 2 for this mini project, I'd like to presenting about layout design. So let's take a look. First, to make a layout design, there are a few steps we need to do. Yes, let's look. For the equation Y equal to A plus B plus C plus G H bar, this is our equation. First part, we need to make a transistor logic diagram. For the transistor logic diagram, we make a Euler path to know how the paths are going from the VDD at the PMOS to the A, to the B, to the C, to the G, to the Y and H. That's the Euler path at the PMOS. And NMOS, A to the B, to the output, to the output Y, to the C, to the G and to the H. They are same at the PMOS and NMOS. Pull up network and pull down network. So, and then after the Euler path, we make a stick diagram. Stick diagram are easier to make a layout at our VMware. So let's take a look how to make from the Euler path to the stick diagram. First part is we need to know about green layer. This green part is the PMOS and NMOS. PMOS and NMOS is the active part. Next, let's take a look how many transistors do we have. A, B, C, G, H. There are 5 transistors. So we make a 5 transistor here as a poly, right? A, B, C, G, H. Then we make a P well and N well, representatively by green box and yellow box. Then let's take a look what connected to the VDD. At PMOS, A connected to the VDD. So we make a VDD output and ground first. So we connect A to the VDD and then the NMOS part H to the ground. Then we look, G and H are connected to the Y or output, and at the bottom part or the NMOS part, A, B, C connected to the output. This is the A part, B and C. A, B, C connected to the output. Next, we take a look. Another connection part. There are C, G and H at PMOS are connected. So we make like this. C and G. Then A, B and C also G are connected. So A and B, C and G connected. So this is a complete circuit IC circuit design. And after that we make a transistor inverter for the layout as a HR bar. Then for the layout design to make a VMware, we pass it to Diza Adi Firdaus. Thank you.
Hello, my name is Diza Adi Firdaus bin Jafar. My number matrix is 211033252. I am doing analysis of layout design. Okay, this is our layout. Layout have a few rules, like example, this metal to active must have contact. So this is contact. Another example of rules is poly to active. Poly must over the active 2 lambda. Okay, let's look for the RC. The RC is a design rules check. So first run we get 28 error. So this is example of error. Poly active. So poly must over the active 2 lambda. Another example is contact active to metal. So contact must center to the metal. So many in this layout we have problem of this, so many. Okay, this is another example. So and well, this is spacing and well. So spacing must be 3 lambda. So I do correction for this error. So let's look to LVS check. LVS check, we have problem on schematic. So this is the problem. This is problem because ABC is parallel and series to G, but didn't have a connection. So we do the correction. So this is the correction and LVS is correct. So for the conclusion, IC is a subject. IC is a subject that focus on basic digital fundamental and IC technology development. So firstly, the most simplified equation, the easier layout can be met. So that can head it to cost and time saving. That also can help engineering fabrication. So finally, for me, that rules for layout must be followed for know the layout is correct or not. Okay, thank you.